Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is Nabila Dafina Putri. My ID number is 410-142-1020. I am studying mathematics education in Universitas Negeri Semarang. Then I will to make a video about a function and how we can prove the function is injective, surjective, or bijective function. Before we proving, we must know the definition injective, surjective, and bijective function. Injective, let f a to b be a function from the domain A to the codomain B. The function f is called injective or one-to-one if it maps distinct element of A to distinct element of B. In other words, for every element y in the codomain B, there exists at most one primate in the domain A. And this is the notation. Every x1, x2 element A equal x1 not equal x2 implies fx1 not equal fx2. Surjective. A function f from A to B is called surjective or onto if for every y in the codomain B, there exists at least one x in the domain A. The notation: every y element B equal there exists x element A such that y equal fx. Bijective. A function f from set A to set B is called bijective one-to-one and onto if for every y in the codomain B, there is exactly one element x in the domain A. The notation: every y element B equal there is exists exactly x element A such that y equal fx. I have a function. Show that the function fx equal 5x plus 2 is a bijective function from R to R. Before we prove with the definition, we can to make the graph in the GeoGebra application. I will input a function in the GeoGebra application for to draw the graphic. Fx is equal 5x plus 2. We can see in the graphic is a function is a one-to-one or injective and onto or surjective. Why? Because in one-to-one function, every y value is mapped to at most one x value. In onto function, every x value is mapped to a y value. So the function is a one-to-one and onto function. And then we must do proving with the definition function. So we can to check if a function injective or not. From the definition, we have x1, x2 element R with x1 not equals to x2. So fx1 not equals fx2. Obvious, 5x1 not equals 5x2 implies 5x1 plus 2 not equals 5x2 plus 2 implies fx1 not equal fx2. Thus, fx is injective function. Step 2, we can do checking is the function is surjective or not. From the definition, we have a function fx is equal y such that y element R. So we can to choose x element R where x is equal y minus 2 divided 5. Obvious, fx equal 5 times y minus 2 divided 5 plus 2 is equal y. Thus, fx is surjective function. So from the step 1 and step 2, we can to conclude if the function 5x plus 2 is a bijective function from R to R. And the second function, I have a function. Let the function f n to n given by fx is equal to x. Now I will to input the function fx is equal to x. From the graph, we can see if the function is one-to-one and onto, but if the function is one-to-one and onto L of n or not, so we can prove it is the function is one-to-one and onto L of n or not by definition. Step 1, we can check if the function is injective or not. So from the definition, we have x1, x2 element n with x1 is not equal x2. So fx1 is not equal fx2. Obvious, 2x1 is not equal to x2 implies fx1 is not equal fx2. First, fx is injective function. And then step 2, we can check if the function is surjective or not. From the definition, we have fx is equal y, such that y element m. And then we choose x element n, where x is equal y divided 2. Because x element n, where n is a natural number, we can put y is equal 1, because 1 is a natural number. So then we can do substitution. X is equal 1 divided 2 is equal 0, 5, which is not possible as x element n. So fx not equal y. So fx is not a surjective function. So we can conclude about fx is equal to x is one-to-one but not onto in L of n. That is all for me. Sorry for my mistake. Wassalamualaikum warahmatullahi wabarakatuh. Bye bye.